14.9, the last sections of acid alkaline. We will talk about the corrosive nature of the corn acid and alkaline in this section. So, corrosiveness of acid are concentrated acid and alkaline. So first of all, you have to know that if it is a dilute acid and alkaline, it will be only irritant only. But if it's become concentrated, okay, then the acid properties and alkaline property will be corrosive because they have high concentration of H plus and OH minus. Okay, so you can check the videos here. That will be very interesting. This one, super acid versus tangerine. Okay, is a very awesome videos. The other one, okay, will be versus SpongeBob. Okay, have a look at that. If you have add some concentrated acid on a cloth, you can see that. Okay, holes. Okay, the paper, the cloth turns brown. Okay, will be often seen. Okay, like that. Okay, big three. Okay, you have to recognize the features, okay, of the Conc HCl, Conc HNO3, and Conc H2SO4. First of all, okay, you will find that the molarity is just like concentrations, okay, or percentage by mass. Means if you have 100 gram of HCl, how many gram is because of the HCl, how many gram will be related to the water, because it is still having water in it. Okay, so you can see that, okay, for Conc HCl, Conc HNO3, and also Conc H2SO4, okay, their molarity will be different, okay, and also the percentage by mass will be different too. If you have a look of Conc H2SO4, 98% of the acid, okay, is due to the H2SO4. Only 2% of water right there. But for this one have 30% of water, this one have like 65% of water. So you can see that, okay, different acid, their concentration or percentage by mass will be different. Okay, so you may ask why, even they are concentrated, why they are not at a very, very high percentage. Okay, so do bear in mind, okay, this percentage will be related to the solubility of acid in water. Because some of them, they may be more soluble in water, some of them may be less soluble in water. So in this case, okay, you'll find that, okay, for HCl, okay, maybe maximum they can only dissolves, okay, 35%, okay, and then if you get more, okay, the solubility, it will be limited, and then the excess HCl will then leave the acid. Okay, so therefore the maximum will be like 35% only. Okay, so different acid, okay, they may be different. Okay, so the unique features, okay, you have to recognize the unique features of them. Okay, so for Conc HCl, that will be a volatile colorless liquid. Okay, the color of the acid are colorless. Okay, actually 3 of them, they are colorless. Okay, volatiles means that, okay, they can turn into vapor easily. Okay, they will turn into vapor. Volatile means turn into vapor. Because it can turn into vapor, so you will see that they may have some acid mist, white film, okay, given out. And because it can be turned into vapor, so they can get into your nose easily. So you will also smell a very strong smell. Okay, so for Conc HNO3, okay, they are also volatile. Okay, they are also volatile and also colorless liquid. But more important thing is, okay, normally you'll find that, okay, it will be colorless. But if you place the Conc HNO3 there for a long time, you'll find that the colorless liquid will turn yellow. This one is related to the NO2 redissolve into it. Where does this NO2 coming from? We're talking about HNO3. Why we have NO2? Okay, most important part, okay, for this feature is because HNO3 can be decomposed by UV. You can see that the bottles, okay, we use right here, okay, we are having brown bottle. Okay, so imagine, okay, you are in a brown bottle. Okay, the UV light from outside, okay, or the sunlight from outside cannot get in. Okay, the light from outside cannot get in easily. Okay, so what you can see inside, okay, will be brown in color, very dark in color. So therefore the UV or the sunlight cannot go in, it cannot decompose to HNO3. So the decomposition of the reactions, okay, is also very important. Okay, you have to bear in mind for these reactions. Okay, you may find that okay, it's so complicated. Okay, we have so many compounds in it. Okay, but no worry. First of all, you have to remember this is a decomposition. Decomposition means that okay, it have one chemical and then become many. Okay, so you can see that okay, on the reactant side we just have HNO3, one of them. Okay, and they will become three different compounds: H2O, NO2, which make the colorless liquid turn yellow here. Okay, and also they will give out O2 as well. Okay, so to balance this one, okay, you just need to remember this number. Okay, 4. Okay, remember, okay, so far we didn't have many equations having 4, okay, as part of the coefficient. This will be the second equation that we've learned. The first one is the iron 3 oxide, hydrated iron 3 oxide in rusting. Okay, so this is another equations with 4 right there. Remember, decomposition, one type of reactant become many products, and also the reactants, this one we have 4 right there. Okay, so this equation very important, bear in mind. Okay, and for the Conc H2SO4, because we have a lot of chemicals in it, only 2% of water. So basically, okay, these chemicals, okay, they are non-volatile. They are non-volatile. Non-volatile, that means that you cannot smell it. They have no acid mist, okay, because with very small amount of water, okay, so therefore it will be very oily, okay, not very liquid, okay, like the other two acid. Okay, so one more extra thing is about other properties. Okay, normally, okay, for the acid, okay, we will say that they have acidic property. However, okay, other than acidic properties, they may have other properties. But in this chapter, it's not very important because in the future chapters, redox, we'll talk a little bit more about that. Okay, but just let you know, okay, for Conc HNO3, they will have a oxidizing properties. For Conc H2SO4, they will have oxidizing properties plus dehydrating properties, but in details we'll talk about that later. Okay, so basically, okay, I just want you to remember the 3 acid for the Conc HCl, okay, that will have some acid mist in it. Okay, while the Conc HNO3, they also have acid mist, okay, but for Conc HNO3, you have to remember they have to be put in brown bottle to prevent the decomposition of the HNO3. Okay, so just try to do once decomposition of the HNO3. Okay, remember you put 4 right there, so after you have 4, you know that with 4 NO2 and you need 2 H2O, and after you count all the O, you'll find that this equation have been balanced already. Okay, so the last one, okay, there will be the Conc H2SO4. So this one we have not much features, you just know that they are oily will do. Okay, so Conc HNO3 will have the acid mist. We have acid mist here. This one also have, okay, and for the liquid, okay, in the middle, okay, you have to bear in mind, okay, they may be slightly yellow, okay, slightly yellow because of the redissolve of NO2. Okay, so last one, just oily. Okay, so basically these 3 pictures are very important, bear in mind. Okay, and then some fun fact, it is not part of the exam, but I think this one is quite nice. When you cut onion, actually there are some chemicals coming from the onion and get into your eye, and eventually, congratulations, you have some sulfuric acid in your eyes. Okay, so you'll find it so painful, the tear will come up from your eyes. Okay, so if you want to know more, okay, just check in this QR code. Okay, I'll have a very simple version to explain what is it. Okay, so how to prevent that? Okay, you can suggest your mom cut the onion in water, or you can freeze the onion before cutting it. But I just want to think about why, okay, why it happens like that. Other training videos, I think you will get some idea about that. And then how about alkaline, concentrated alkaline? Are they corrosive? Of course, yes. Okay, so if you remember in form 2, okay, we did put the chicken feet, okay, into corn sodium hydroxide, and after like it won't be like the previous videos, okay, ask you to watch the super acid versus SpongeBob, okay, it will just like immediately react, okay, like that way, okay, but it take a few days, okay, you'll find that the flash, okay, will just peel off and things like that, okay. They are also very corrosive as well. Okay, so last part, okay, how to dilute concentrated acid. In your textbook, talk about concentrated acid, but I would like to draw your attention, not only concentrated acid, but also alkaline and also concentrated household chemical. For example, bleach, okay? All kind of these concentrated chemicals, if you try to dilute it, okay, you have to follow three important steps. First, okay, you need to add chemical slowly into large amount of water with constant stirring. Okay, so how to memorize it? Easier. Okay, just remember this picture. Okay, if you count alphabets from A to W, you'll find that A will go first. So small amount of A, that means acid or alkaline, add into large amount of water from A to W. Okay, slowly, and together you need a rod with constant stirring. Okay, so just memorize these one, the pictures here. Okay, A add into W with constant stirring. Okay, so these three statements, okay, are make together will be 2 marks in public exam or 3 marks in public exam. Bear in mind. Okay, so how to protect yourselves in the process? Pretty easy. You have to wear safety goggles or wear safety gloves. Sometimes, okay, if at home you cannot do that, but maybe in the lab you can like carry out experiments in fume cupboard. Okay, so do remember, okay, never do it vice versa. That means you don't put water into acid. Okay, if you put water into acid, that will be a big problem because mixing corn acid with water is highly exothermic. Highly exothermic means lots of heat will be given out. So if you have like the beaker like this, if these are the acid, when you put the water in it, maybe the water get into here, and then it will be highly exothermic, give out a lot of heat, and then the water, they may turn into steam, okay, immediately. When it turn into steam, you have to go out, then it will make the acid to sprout out, okay, or sprout out, okay. So therefore, it will just hurt people around, okay. So never do it around, okay. Vice versa is not okay to do that, okay. Acid to water. So some examples, okay, in class practice 40.9, okay, I'm not going to talk about this one, okay, because it's pretty easy. Just one reminder, okay, your protective methods that you're going to suggest have to be relevant to the situations, okay. Don't tell me every time, okay, wear safety gloves, wear safety goggles or things like that, okay, because for example, okay, just have a look of B. You see that the vapor of corn acid, okay, is corrosive. How to protect yourself from the vapor? You tell me that you have to wear safety gloves. I think it is not very related to that. Okay, so therefore maybe you have to like stopper the flask after you use it, do the experiments in the film cupboard. Things like that would be more relevant. Okay, so if it is irrelevant, okay, sorry, okay, you won't get any mark from that. So lastly, okay, to summarize these videos, dilute acid, irritant, concentrated, corrosive, features of the big three. Okay, remember the 3 bottles just as we mentioned. The first one, HCl, you got acid theme, okay, strong smell, and then the HNO3, okay, remember it will be brown in color because it will be decomposed by the UV. The acid will be decomposed by the UV. Remember 4, okay, and decomposition 1 become many, okay, that will be easy for you to remember. Okay, and the last one, okay, that would be oily one, okay, that will be H2SO4. Okay, you have small amount of water, only 2% of it. Okay, so how to dissolve it, how to dilute the exit in the process. So you have 3 steps. First of all, okay, add small amount of chemicals always slowly into large amount of water with constant stirring. Okay, safety precautions, you may wear gloves, goggles, and also perform the experiments in the fume cupboard. That's all for this video, and also this is the last sections of this chapter 14. Okay, time to finish your chapter exercise. Okay, and also write notes on that. Okay, bye bye.